Last lecture, we discussed Faraday's law of induction. Now let's talk about a typical application, generators. Here is a simple model for an AC generator. Please look at this figure. There are two magnets producing a magnetic field in which the loop is rotating. The end of the loop are connected to the two slip rings, which could be the output terminals of the generator, through the two stationary mechanic brushes which is connected with the slip rings. Let's see the working principle of a generator. When the loop rotates in the field, the angle between B and the plane of the loop is changing with time. So the magnetic flux changes with time, which results in an induced EMF in the loop. The flux through the loop at any time t can be calculated. Phi B equals B dot S equals B times S times cosine theta. For convenience, suppose at the beginning, B has the same direction as the normal to the plane of the loop, then theta equals to omega t. If the loop has n turns, the flux penetrates the loop n times. So the flux should be n times phi b. Then according to Faraday's law of induction, the induced EMF in the loop should be this one. Epsilon equals to minus n times d phi b over dt equals nba omega sine omega t. This is a plot of the EMF as a function of time, showing that the EMF varies sinusoidally with time. Obviously, the maximum EFM has the value of nba omega when the field is perpendicular to the normal to the plane of the loop, while the EMF is zero when the field is parallel to the normal to the plane of the loop. Now, if we need a DC generator, how to design a model? We know for a DC generator, the polarity of the induced EMF should remain the same during the rotation. Please look at this graph showing the configuration of a DC generator. Similarly, two magnets produce a magnetic field in which the loop is rotating. But we notice that the contacts connecting to the ends of the loop is a slip ring called a commutator instead of two rings in an AC generator. We understand that the polarity of the induced EMF reverses every half cycle, but in this configuration, because the brushes to the split ring reverse during the same period, the polarity of the output voltage will keep the same, so that we could obtain a direct current. Well, next I'm going to talk about inductance.